Okay, let's discuss velocity versus time plots. In this case, the plot gives the velocity at any time. Instead of position, it gives the velocity. Now, there is a new thing here. The area under the graph gives the displacement. The slope gives the acceleration. So this is for position graphs, the slope gives velocity. For velocity graphs, the slope gives acceleration. But notice here, we don't get position from velocity graphs, but we can get a displacement. Now, looking at the graph that we have here, what this one tells us, we have a velocity that starts at 0, at time t equals 0, and then it increases at a constant rate till it reaches 3 here at about 1 second, and then it stays constant for 2 seconds, and then it decreases till it reaches 0 here at about 4.2 seconds, and then it increases again, but in the negative direction, beyond the 4.2 seconds. Now, let's answer the questions here and learn from them. What is the velocity at t equal 2 seconds? 2 seconds, that's here. So we just read it off. That's 3 meters per second. Now, the next question, what is the displacement between t equals 0 and t equal 3 seconds? Okay, this is 0, 1, 2, 3, that's 3. Now the displacement is the area under the curve. That's this area here that I marked. So what would that area be? It's the area of, let me change the color, or let me use the highlighter here. So it's going to be this area here, a rectangle, plus the area of this triangle here. So let's start with the rectangle first. The rectangle height is 3 meters per second, because this is in meters per second, of course. And the width is 2 seconds. So height times width, or length times width, is the area there. So area 1, let's call it, or area sub r for rectangle, 3 meters per second times 2 seconds, so that would be 6 meters. Now the next area, let me choose a blue color here. That's this triangle here. Now the area of a triangle is also height times width over 2. So in this case, the height is still 3 meters per second. The width in this case is 1 second over 2. So it is 1.5 meters. So my overall displacement is 6 meters plus 1.5 meters. That would be 7.5 meters. Let's go back to the original in color. Now, what's the average velocity between t equals 0 and t equals 3 seconds? You forget about the graph. Remember what average velocity is. Average velocity is displacement over time. So in this case, the displacement is 7.5 meters. And time is 3 minus 0, so 3 seconds. So it's 7.5 over 3 meters per second. Whatever that is, I'm not calculating the number, but 7.5 over 3. Okay. What is the change in velocity between t equal 5 and t equal 3 seconds? So here it is asking us about v at 5 seconds and v at 3 and the difference between them, minus v at 3. What's v at 5 seconds? So this is v at 5 seconds. Okay, so I'm going to approximate it here. So it looks like it is minus 2. V at 3 seconds, it is here is 3 meters per second. So minus 2 minus 3, that would be minus 5 meters per second. So then it is asking about the average acceleration between those times. So the average acceleration would be change in velocity over time. So that would be minus 5 meters per second over 2 seconds. So that would be minus 2.5 meters per second. Okay, a few things to pay attention to. Let's go to the eraser. We get the velocity by reading it off the plot directly. For example, here we are at 1 meter per second, here at 2 meter per second, here at 3 meter per second. Acceleration slope of the graph. So here, for example, I have a positive acceleration because I have a positive slope. I can calculate the slope. For example, rise is 3, run is 1, 3 over 1 is 3 meters per second squared. That's my acceleration here. No acceleration here since my slope is 0. And negative acceleration here, that's what we calculated here as minus 2.5 meters per second squared. That's the same negative acceleration here. Now, remember this whole portion here, we are moving in the forward direction. We never turn back here. It's all in the forward direction. But the velocity increases, reaches a maximum, and then decreases. When do we go back? Here. That's when the velocity is in the opposite direction, below the horizontal axis. That's we have negative velocities, so velocity is in the negative direction. Displacement, we get it as the area under the curve, as was mentioned earlier. For example, if we go to another part and asked to find the displacement between, let's say, 4.2 seconds and 5 seconds, so that will be the area of this triangle here. If we were asked to find, let's say, the displacement between here and here, that would be this area plus this area. Remember, this area comes out to be negative, so it's a negative plus a positive. It comes out negative because we have negative heights here, negative velocities. So it's going to be this area plus this negative area here.